Um, so, I'm going to minimize that. Where did it go? Is it here? There it is. So now I'm recording. So the first part of a circle, so this is all about if you have a circle and you have a piece of pi of a circle, that has a special name, okay? So if you have a piece of the pie like this, and you shade this area in, okay? Eraser, know that this thing, this piece of pie has a name. Anyone know what that's called? This
A sector.
how do you know that, Reese?
Because we read about it.
This is called a sector of a circle. Okay?
It was in the book.
This is very similar to arc length. Okay? And there's a formula. Anyone want to guess what the formula is? If I know that, if I call this angle N. Right, yeah. So it's just N over 360 times pi r squared. That's how you find the area of a sector of a circle. Okay? So, hey, hush. So let's do one, okay? Say you have, a circle that looks like this, and all I give you is this, like this, and this like this, and I tell you that this is a 90-degree angle, and I say, shh, and I tell you that this is 6 inches. Find the area of the sector. How do I find the area of that sector?
In exact or
Exact, yes.
is it non-pi?
Is it 9 pi? Let's see. It would be 93/60ths, right? Or 1/4, yes, which is 1/4 of pi times 6 squared, which is 36 pi over 4, which is 9 pi. Tatum gets a gold medal. Very good. Nice job. Okay, and that would be square units. If they ask you to the nearest tenth, then you round to the nearest tenth. I'm going to give Tatum a point. Who passed out papers? Tatum, you get 2 points today. Who's going to collect folders? Oh, who collected folders already? Abby. Abby and Reese. Abby and Reese. Go ahead. Abby. Abby, help collect the folders. You and Reese, yeah. Wait, I have to pause. It's time. This is called a segment. Segment of a circle. Segment of a circle. What pieces would I have to subtract to find the area of that segment?
We find the area of the sector and then subtract the area of the triangle.
Right. So that is equal to the sector, very good, the area of the sector minus the area of the triangle, area of the sector minus the area of the triangle. Fine. So let's so that it depends on the problem, right? On what you're going to see. But let's say that I have, say I tell you that this is 120 degrees right here. Oh no, I can't tell you that that's 120 degrees. I could, but if I told you that's 120 degrees, you would have to know the length of that, right? Yes, because you have to know that that's the height of that triangle. Let's say that this is 8, and let's say for math, what would that be? 60, 30. This ends up being, I know, because let's see, 60, 30. That would end up being 4. I know, because you'll learn about this later on. but this ends up being 4. So you would at least have to know those two things, okay? If you did not know that, it might be a right triangle, and then you could go base times height divided by 2, right? So you have to know how to find the area of the triangle, okay? So this would be, how many 3/60ths? 120 3/60ths, right? Of pi times what squared? 8 squared minus, how do I find the area of the triangle? Base times, oh, I don't know the base either. What would that base be? Let's just say that that base is 4, 8, it's not going to be 10. It's going to be about it's going to be like 6.2 or something like that. It's going to be some weird number, okay? But if I did do that, I would go 6.2 times 4 divided by 2, right?
Times 4.
Base times height divided by 2. So I get 120 3/60ths, which is 1/3 of pi times 64 minus 6.2 times 2, right? Minus 12.4. So if they ask you for an exact answer with this type of problem, what you do is you write it like this. Minus 12.4. This is exact. Alex, you want to take some notes? You don't want to take any notes? That would be exact. If you want to know the rounded up answer, then you plug it into your calculator and get the answer. Question? Preguntas? That's how the area of a sector. The next thing, am I going too fast?
I can't see what.
You can't see. The next thing we're going to talk about is called an annulus. Okay? An annulus is like a flat donut. Alright? So this thing, am I in your way? This thing, if I have a circle, and then I have another circle inside the circle, this ring around here, okay, that's not, you get the idea, right? This thing out here,
You should definitely spend a lot on
drawing that. Hello! Why are you late? I'll find you. Okay. So this shaded area, let's keep working.
Do you not have a paint bucket tool?
A paint bucket tool, do I? Color? I don't know. Alright, I'm just gonna tell you that this thing is called an annulus. A-N-N-U-L-U-S. The way you find the area of an annulus, you take the area of the big circle and you subtract the area of the little circle. So if the big circle has a radius of r, and this has a radius of little r, then the formula is, guess what? Pi big R squared minus pi little r squared.
Whoa.
Isn't that complicated? So let's say I were to tell you that this piece from here to here is 2 inches, okay? And this piece from here to here is 4 inches. 4 inches. Find the area of the annulus. Okay? Uh-oh, Moby is freaking out. Paint is working. I gotta move closer. Find the area of the annulus. That's what that says. A-N-N-U. Who can tell me how to do that? Go ahead, Abby.
You add 2 and 4 together.
Right.
To get 6, and then you square 6,
Okay, minus pi times,
4 squared.
very good, right? Pi big R squared minus pi little r squared. So this is 36 pi minus 16 pi. How many pi's do I have altogether? 20 pi's, right? Which is 3.2, about, so that's going to be like 62.63, 3.14,
62.8.
62.8, somewhere around there. And you would put your units inches squared, okay? This is exact, this is approximate, approx. So now where these get tough, I'm going to just do one where we have to work backwards, okay? You ready to work backwards?
Maybe.
Maybe, okay. Or do a more, or slightly more complicated problem. Okay, so say I were to give you, which you will see in your homework, say I were to give you a problem that looks like circle, circle, angle, angle, no, not a circle, I meant to draw an angle, 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 and then I'm going to shade this part here, and this is not going to be to scale, just so you know. So the area of the shaded part, the big R is 8, okay? So this is 8 from here to here, 8 from here to here. And this, even though it doesn't look like it, is 2, okay? Find X. Oh, I have to tell you something too. The area is 10 pi. Find X. Who can tell me how to set that up?
N over 360 times pi 4 squared.
Pi 4 squared?
Pi times 16. As it
Close. And X over 360 times pi big R squared. What's big R squared? 8 squared minus pi little r squared. What's little r squared? 6 squared equals 10 pi. Do you guys understand what I did there? Why that is the way it is, right? It's this part of the little circle. So now what I would do, okay, this is X over 360 times, you could pull the pi outside, right? What's 8 squared? 64 minus 36 equals 10 pi. What could I cancel out from both sides?
Wait, why would
Because the reason I factored out this pi is because now I can cancel it out from both sides. See? Do you see what I did? Okay. And then what's, so you get X over 360. What's 64 minus 36? 28? 28 equals 10. And then you just have to solve for X. So, let's see. Does this reduce? 4 goes in here 7 times. 4 goes in here 90 times. So you get 7 over 90 X equals 10. How did I get rid of the 7 over 90? Multiply by 90 over 7. Multiply by 90 over 7. Oh, this isn't going to come out nice, is it? So I get 900 divided by 7, which is, because, right, that's how you get rid of a fraction, and it equals X. And so what is 900 over 7? It's not very neat. But it is about 900 divided by 7 is about 128.57 degrees. 128.6 degrees. Okay, so that's kind of a not a very nice, neat one. But I think the problem that I set up was different. Oh, I see what I did. All right, but that works. Questions?
Wait, where did the X go?
The x went, we solved for x, right? So x is over here, right? So it was 7/90ths of x equals 10, and so I multiply by the reciprocal. So I get 90 over 7 times x, and then I get x equals that, and there you go, okay? No, it's just 128.6 degrees, right? Because you're finding an angle. So your homework is page 455, 1 through 12. Show, work, go, Broncos. Oh, the football season's over.
Yeah.
That's good, so now they have a fresh start, right? Okay.